Hi everyone, my name is Alexis. I've been making Spark AR effects for Instagram since the beta, and today I want to take you through a tutorial that covers my entire creation process for an effect, from concept ideation and research to publishing. I've been seeing a ton of tutorials that talk about ideation and actually coming up with interactivity and UX, so I wanted to walk through that today. My personal Instagram can be found here, once I learn how to link things on YouTube, and my AR studio where I do work for clients called Pond Skater Studio. That Instagram will be linked here. So let's get started. I'm going to take us through 4 overarching sections. So we're going to go through concept ideation, 3D modeling and texturing, building things in Spark, in the Spark environment, sorry, I have the hiccups, and publishing. So under concept ideation, we're going to go through collecting reference imagery, doing, motion studies, planning interactivity, and designing the UX and UI concepts and how the user is going to interact with your work. For the 3D modeling and texturing section, because I am a masochist, we're going to be doing that in Maya. I want to learn Blender, but I downloaded it a month ago and I have yet to open it. So we're going to go through low poly modeling in Maya, texture creation, which is intrinsically part of the 3D process, UV unwrapping so that we can create those textures properly, and maybe a little bit of normal map stuff. And then for building in Spark, we're going to do the whole gamut. So we're going to go through object placement, texturing, interactivity, setting up the patch editor, and adding detail and little polishing details to make the effect just that much better. And then we're going to go through the publishing process, which is actually pretty simple, and the most important part of the publishing process, which is being patient. Before you begin any creative project, you have to ideate and come up with a concept. In this case, we're going to be building a Bopit effect. So this is kind of a special example since we're using existing IP. But it's always important to collect reference imagery, make a mood board, find something for you to look at when you're creating your concept. In this case, we need to pull what the vintage Bopit looked like so we can make an accurate 3D model. Vintage original Bopit. So that's what I want. So let's type in original and see what the mechanics are. Okay. All right, so we have 3 main mechanics. Pull it, which has him pulling out the thing that's off the screen. Twist it, which is on the left and he's twisting it. And bop it, which you're hitting. So in this case, I need to translate those 3 things to either facial interactions or body interactions. But because we're doing Instagram, it would be easier to do facial interactions. So I'll take some notes. Let's just call this Bopit effect interactions. And sometimes I do this in a sketch pad. I can't spell. But for the sake of this tutorial, we're going to do it online. So 3 main interactions. We got bop it, twist it, and pull it. Blank project. We're not actually starting. I'm just gonna reference what our options are here. Interactions. So here are our options. We can blink, raise our eyebrows, lower our eyebrows, smile, which is relatively new, head nod, head rotation. So this is just recording the states of your head, which we could utilize possibly to do like, a forward lean state is bop it and a left right. So that's an option. Let me write that down. So bop it, twist it, pull it. Head rotation. Since bop is in the middle, I would say forward for that one. And then left turn, right turn. So if we build the bop it, twist it would be on the left. So this could also be head rotation. Oops. Left. And pull it, head rotation. Right. Now this is just one set of options. Good to mention that most of these facial interactions are a little bit awkward for people to do, especially if they're in public, but you have to think about the objective of your effect. And the objective of my effect is to be a little bit uncomfortable and funny. So I think it's okay if you push the user to do something that they might not necessarily love doing. I don't think the expressions work as well with what we're trying to do, because you want the motions to be intrinsically linked to what the user is doing so it feels more natural. So I want to keep head nod for Bopit. We have to test how well Spark reads all of these things. So for example, with option 1, I'm wondering if a forward head rotation, the left and the right nod, how sensitive that would be, and if these could easily get mixed up. Because the last thing I want to do is have users doing interactions that could be mistaken for one another and have them be awarded points or deducted points incorrectly. Because essentially this is a game. So what this is going to do is, as you bop it, twist it, pull it, whatever this man is doing, you're going to get points. And then I haven't decided the functionality on the points yet, but either maybe you reach 10 and you win, or if you miss something, you lose a point, or maybe it just makes a happy noise like the Bopit does. We'll see, but we have to find a way to make this, like, gamify this a little bit more. So the ideation portion of this effect is actually a little bit easier because Bopit is not only a game that already exists, but it has rules. So I wanted to go back because I've never seen this Bopit before, and it's not the one that I'm making, but I wanted to refresh myself on the rules. Okay, this is important. 1 point each time you get it right, but if you're too slow or you get it wrong, the game will end. So I think that's actually pretty important because that kind of outlines our gameplay. And we'll have to figure out a way to display score. It'll probably have to follow the face because it's text. But I think having a score will be interesting, and it'll make this more shareable and more fun. And then we can also, if I'm feeling up to it, integrate this as well, where as you're doing well, the game gets faster. So I'll have to figure out, I think that'll be pretty easy to do with logic and numbers, but for anyone who knows me, I'm not very good with anything that's logical, so that'll be hard. So that should be easy enough to do. Even though I've never really done games before, I think that this should be pretty achievable. People using this effect won't inherently know what to do, so we're going to design a set of icons to guide users towards which head movements to do and how they correlate with each button on the Bopit. I am using Illustrator for this because it's easier to make vector art, things that look like icons and that are scalable, and then we're going to export this and use them as textures in Spark. In terms of 3D modeling, I do want to apologize for this super sped up version of me creating this model. I wanted to do a step-by-step of how I made this Bopit in Maya, but it actually took about 2 hours, so this tutorial would be 4 hours long instead of 2 hours. So instead I just want to touch on some basic points. It's really important that you make low poly models for Spark or any social AR. Low poly just means that you start with a really simple shape and you keep the faces as minimal as possible. So it's a really simple mesh, and then make it look more complicated with textures. For this Bopit, I started with cubes mostly and a couple cylinders, and then I modeled it and I changed the shape to look just like the actual Bopit. I added some screw holes and some other details. For the twists on the pullet, I used the multi-cut tool in order to cut through that mesh in a spiral. And the Bopit button and twist it pullet knobs are separate models because they're going to move and twist. Now let's go over how we're going to texture this model. First, to kind of plot out how each color is going to sit and on what parts, I am adding new materials to each piece of the Bopit and changing the colors. We're going to redo all these materials in Spark, but I just want to be able to reference this stuff and name my materials, so when we do import these in Spark, I know what material goes with what object. For the Bopit button here, we're taking the UV and we're using the planar mapping options to get kind of like a cross-section of the front of this Bopit. So when we do the text design, it'll map perfectly flat to the top of that button. Now the hardest part of this was doing the UV unwrapping for the body of this Bopit, because this is one piece. So it's a cylinder and a flat sphere, but I manipulated them and changed them enough that it started to get a little intense and a little bit complicated. But there are a few parts to the body of this Bopit. So the whole thing is black, but the left side says twist it and the right side says pull it. So what I'm doing right now is I'm isolating the part of the mesh that says twist it, and I'm going to break that apart. I'm going to separate it from this mesh and move it up so that I can add those drawings and add that text without having it show up on other sides of this model. And then I'm doing something similar to the right side. I am unwrapping this whole cylinder and laying it out flat so that when I make the design on this right side, which is a blue kind of wavy pattern, it wraps around like a tube of wrapping paper. To do this, I cut all around and made a seam for unwrapping, and then I separated that from the mesh in the UV mode. And then you can see there on the right, it's kind of laid out flat. And this part was also pretty difficult to do. So the Bopit is turquoise on the top and the bottom around the button. What I ended up having to do is select every single one of those faces, duplicate them as a separate object, and then move that object to a different part of the UV so I could color that blue without affecting the other areas. The texture creation for this effect is a little bit easier than other effects because we have a pretty solid reference. So what I did is I took a Bopit texture from online, I made that purple background, and now what I'm doing is I'm retracing the text to make it cleaner and crisper on the edges, kind of erasing artifacts and things that we don't need. I added a drop shadow just to make it kind of stand out a little bit, and then I exported that for the Bopit piece. In terms of the body, we need to make every single part of this texture. So if you'll notice, I took screenshots of the UV maps from Maya and I'm building over those so I know where to place things. So I redrew the pull it and the twist it text, and I'm placing it over those pieces of the UV map that I separated for those specific areas. What I'm also going to do a little later on is paint the whole thing black. Oop, there I did it, because the body of the Bopit is black. And then that blue area you saw that we separated for both the Bopit button and the handle on the right side, I'm just making that pattern and putting it in a way where it'll wrap and look like it does on the Bopit. So we'll see here once I place that texture, everything wraps perfectly because we UV unwrapped. Because we carefully unwrapped our UV, and it looks pretty good. Adding little details to an effect is a really good way to take something and kind of heighten it into a more interesting experience. So what we're doing here is we are building out a 3D model for the instructions. So when you get a twist it, bop it, or pull it instruction from the device, I also want something visual accompanying that, because users won't be able to hear the instructions until after they record their story. So what we are going to build out here, as you could see, a little cylinder, which once I texture it, I am going to have a little like twirl wrapping around the twist it. So what I did is I took a screenshot of the UV map so I know where to put my bar. I'm changing it to the green color that we're using for everything. And then I'm going to export that and put it back onto my model in Maya so that it looks like a little ribbon is wrapping around our model that we just created. And there we go. It looks like a cute little ribbon. We are also going to add a little flare for the button as well. And we're going to actually build that out in Spark on a plane. We don't need a 3D object. So that was what that circle was for. And then for pull it, I wanted to build out an arrow icon. So as we do with everything, we are exporting all of this stuff at 512 and then putting it through tiny PNG so that all of our textures are as compressed as possible. And then what I'm doing now is I actually want these instructions to animate in and out. So I am creating an animation sequence where the arrow slowly, bit by bit, comes onto the screen. Now there are better ways to do this. You can do this in After Effects. You can do this in Spark with SDFs, but I chose to do it right in Photoshop just because it's so simple. It's only 10 frames, and it'll be really easy for me to compress it by hand and make sure that the animation sequence isn't too heavy. Okay, so now we're going to start the Spark portion of this tutorial, which is objectively the most important. So I am going to start with the eye color template, just because I think it'll be fun to integrate some eye color changes into what we're making, and I am too lazy to do this from scratch when there is a template that already gets us started. So, biggest thing that I add into this template is that when we close our left and right eyes, we want to make sure that this turns off completely, and that for whatever reason is not automatically in this template. So we're going to add a not, which negates it being visible. Sorry. If you don't have a not, then it'll be invisible when your eye is open and visible when your eye is closed. So you just want to flip that. So let's see, what was that one? Oh, let's not do that. Let's do the container. So another good thing that we're going to go over during this tutorial is creating non-destructively, so using null objects and containers and affecting those containers in the patch editor instead of the object itself is a lot, like it's a good way to work, because if you need to switch an asset, then it doesn't break your whole setup because you had something affecting the asset itself, but the container around the asset. And then see here, if we close your left eye and your right eye, it'll make the little contact disappear. And we're gonna mess with the eye color later, but I think the first thing we're gonna do is we're gonna import the Bopit into our project. So like I just talked about, let's make a folder or a null. Think of null objects as folders so that we can work non-destructively, and I'm going to call this Bopit parent. If you're familiar with 3D programs, then you'll be familiar with, parents and children, and we're just going to use that syntax to make this a little bit more straightforward. Okay, so let's find our Bopit. So I exported the most recent Bopit. I believe it's the one with no history. No, we want the textured one, and I'm going to turn this green so that I keep my files organized. Okay. So I chose to make this in FBX because when I exported this as a DAE, let me see if I still have it, it was absolutely huge. So the file was 1.7 megabytes, and as an FBX, it was 500 kilobytes, which is a lot smaller. So let's go to our Bopit parent, and here's our Bopit texture. Now once you have imported your 3D model, if you already have textures applied like what we did earlier, Spark is going to, as a default, not have them compressed, as a default have them compressed. We don't want that. So let's turn off the compression. Everything else I believe is just a solid texture, but see how we labeled everything and it all imports over, which is really nice because we don't have to go and redo that, and we know what materials go with what. My computer fan is starting to spin at 11,000 miles per hour, which means that we are doing something right. So let's drag our Bopit into the scene. Looks beautiful, doesn't it? Now what's happening here is that the face mesh that we have the skin smoothing on is intercepting with the Bopit, and we don't want that. There are several ways to fix this, but what I'm going to do is I'm going to put this on a new layer, and I'm going to call it add object and children. So you want to add the parent folder here and everything inside of it. We are going to name this new layer Bopit base, and that'll be the base layer. And then we're going to move it to the front, so it sits in front of our face mask, so no matter where I go, I'm not going to intercept that face mask, which is good. It's just the skin smoothing, but it was including our little Bopit here. So now we have our Bopit in the scene. Looks pretty good, if I don't say so myself. If I do say so myself. Now we're going to take some of these flat materials and we're going to texture it, but first, what did I tell you all I would do first? Object placement. So let's do placement first, and then we'll texture. Let's orient the Bopit itself instead of the folder, just in this instance, because it'll be so one-to-one. So we want this to be exactly straight. So let's type in 90, and then this will be what? Oh, it's upside down. No. First we gotta figure out which is the front of the Bopit. This is the front of the Bopit, so let's type in 90 again. And then for whatever reason it's completely upside down, so we're gonna go boop and make that, oh, negative 90, got it. Not sure why it flips that so much from Maya, so this is good. Now in order to make this game more interactive and feel a bit more relevant to being an AR, we're gonna have the Bopit, sorry, I have the hiccups, move with the face. So there are two ways to do this. There are probably multiple ways to do this, but we're gonna talk about two. So the one way is I could drag this into the face tracker. Boom, Bopit, glued on the face. I don't like that for this type of effect because I think it's a little bit too literal and it looks like the Bopit is part of my face, and I don't want it to be part of my face. I want it to be following me like a little ghost friend. So first let's do this. I'm also going to attempt to teach you all how to keep an organized patch editor, even though I'm not very good at that. So we are going to comment around this, and we're going to call this eye color. Sorry, my laptop is moving around. And we're going to make this eye color purple, because the eyes are purple, and that's just how I'm going to remember. I'm going to keep that to the left. So now, let's start to build the logic for the Bopit parent null and how it's going to move with the face. So we already have the face tracker here. I'm just going to extend it. Instead of eyeball, all we want is the 3D position of the face and the 3D rotation. So I'm going to take the 3D position over here, and I'm going to unpack it. And I'm going to do the same thing with, that's the scale, can't see, with the 3D load rotation, unpack. Okay, so now that we have these two, top is position, bottom is rotation, I'm going to use one of my favorite patches since I figured out what it does, exponential smoothing. So what this does is it takes the movement, like you saw earlier when I had the Bopit just part of the face tracker folder following the face literally, it takes that and it smooths it out. So if this position is 0 and this is 1 and this is -1, it slows it all down by a factor of an exponent, I'm guessing, because it's called exponential smoothing, and it makes it follow the movements with a little bit of a delay, which I think looks really nice and works a lot better for stuff like this. So we're going to take the position, and then we're going to use a pack patch here. Now we may need to add some patches to tweak in between, but for now let's just do this so you can see what this does. See, look at that. Now this is following a little bit slower than I'd like, and also if we go here into our scene, boop, 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 it's very far behind the face. So XYZ, this is the Z axis. Let's do an add patch here, and we want to keep everything sort of neat. I'm going to add 2 more add patches. And I know there are probably better ways to do this. I am not the shortcut queen, but maybe one day I will be. Alright, so now we can make some adjustments. What just fell? Something fell in my room. I don't know what it was. Okay. So the Z, we see it's way too far back, so we're going to add a negative number. That's wrong. We're going to add a positive number. Alright, so 0.5 puts us about, I would say this is right in front of my face. So let's see if my face tracker is here. So the Bopit is literally in my face. I think we want it to sit a little bit more in front. So when we see where it is and when we have the rotation going, it makes more sense. Let's do 0.7, way too much. 0.55. That feels decent. So it's like kind of right where my nose is. Maybe, let's do 0.58. Okay, so that feels good. In terms of size, if I'm holding my phone, this feels like an okay size for the Bopit. We can scale it in a minute, but we don't want it to be so big that it goes out of the frame and someone has to hold their phone like this. And we don't want it to be so small that you can't appreciate the beautiful model that I made. So maybe we'll make it a touch bigger, but we'll do that in a minute. Just a little bit so that the Bopit part is centered. I think that makes more sense than having the whole model centered. And then we obviously have to move it down so that people can see their own face. So this is pretty funny to have it on your nose. I might keep it on the nose, actually. We'll see. We'll decide later. Let's move that down. Oh, way too much. And down is going to need to be a negative number, 0.1. That looks pretty good. Maybe a little lower, 0.15. No, 0.12. Yeah, that looks nice. So people typically like to see their own face. And then let's make it the tiniest bit bigger. And we're going to do that by making the parent bigger, because like I said, if we somehow have to switch out this model or, I don't know, adjust something, we want all of our adjustments to stay the same. So like down here, we were affecting the parent, and here we'll be doing the same thing instead of the model itself. So let's make this 0.1. You don't want to stretch it, so you want to keep all these values the same. That feels good. And we have to keep in mind that we're going to be like moving our head, because I want the Bopit to move less than my face is moving. So let's divide this by 0.5, by 2, sorry. Simple math. And then attach it here. We have to set up the logic for the rotation. And it's going to be about the same as the position, except that we don't need to mess with the orientation, because I like how its resting rotation is here. So all we need to take in the patch, and the exponential smoothing we will keep, and then we will take the rotation of the parent. Now let's check this really fast and just see how it rotates. So this is fine. So we're going to take the parent rotation just like we did before, so we don't affect anything oddly, and we're going to attach that. And right now it's divided by 2, so it's not rotating as much as it could. Boop, boop, boop. So that's pretty good. Let's see what happens. Hopefully it doesn't break on me. So this is when the rotation fully moves with the face. So if we test it with our back motion, our front motion, and our head shake, I kind of like the full rotation instead of the capped rotation, but maybe we'll just do a slightly capped rotation, like 1.1 or 1.2. So it softens it just a little bit, but I like how that's moving, and I like how that's looking. So in terms of our basic setup with our motion of our 3D object and how it interacts with the scene, I think we're good. So let's, again, stay organized. Boop. So I'm going to move this down. You'll all have to excuse me, I'm working with trackpad because I refuse to buy a mouse because I am a fool. So let's comment around, and then I kind of just want these to line up so that aesthetically everything looks nice when I'm done. We're going to call this, oh please, just a line. Okay, so this doesn't want to line up because we just nope, don't fight me. There we go. Okay, we're gonna call this one Bopit Object Orientation. Doesn't really matter if you spell things right, because this is just for you. And we're gonna make it blue because the Bopit is mostly blue. Well, it's a turquoise. Okay. So the basic object orientation is done. We do have some other elements that we need to place in the scene. Still the hiccups. Which include the icons that we made that are going to kind of guide users towards, how to use this effect. They're not instructions, they're just icons, because Spark does not allow non-standard instructions, and I would never break the rules, so I'm not. And then we also have the little highlights that are going to show up when you actually complete the motion. So we made a twist you saw, and then I'm going to also implement the circles and the pull. But first, we want to make this actually look like a Bopit. So let me pull up our textures. So we already made all of our textures, but lighting is almost as important as the texturing itself and how you choose your materials. So let's go to reference imagery. Pull up our Bopit. Boop. Okay. So there's our Bopit. Move it down. Okay. So first thing that I notice with this Bopit in particular is that the yellow on the twist it is a lot less orange. So this, and it's also kind of shiny, so you can't see it in this picture, it's not very good. But all of this plastic has like a sheen to it. So there are a few ways to achieve this. I think that we'll do the simplest way, which is just to make this into a physically based material. Now what happens, oh, it already looks so much better. What happens when you take a material that you had made outside of Spark and you change like the type, or I guess these are textures and other programs, is it jumps down to your materials folder, whereas before it was housed in the folder for that model. So it's down here now. It actually looks a lot better. It looks a lot less orange just because we changed it to physical all of a sudden. You can see my little recording thing. Let's just move that down and make me a little bigger. Hello. Okay, so this looks pretty good. It's a little bit too stark with the shininess, and also, you know, with these materials, if you make it more metallic, it darkens it. So there are a few ways to get around this. So we're gonna make first the roughness a little bit softer. We're gonna move this back. Let's see. So that has a decent sheen to it. Looks pretty good. I think adding an environment might help, because in real life, when you have an item that's shiny, it reflects like your environment. So you can kind of see my fingers and my phone case. You're not ever gonna get something like that that's accurate in AR, just because like this is reflecting a scene that your camera can't see. Maybe if you had a 360 camera and you were somehow making an AR effect for that, then you would be able to make correct mirrors. But for now, we have a flat camera input and we're faking this kind of stuff. So let's add an environment. I don't need to make a fancy environment because everyone's going to be in a different place. So let's just pick a default that we think would be fun. So I'm guessing most people will probably test this indoors because it's going to be kind of embarrassing with all the head movements. Let's see all of them. Are any of these inside? Bathroom. I kind of like bathroom, so let's try that. We're going to import it. Oh, I think it worked. Oh wow. Depending on how we rotate bathroom, it lights this very differently. So what an environment does is it takes, Spark takes the lighting values from this and it uses it as a fake reflection onto your object. So it's going to affect how the light strikes it. The rotation doesn't really matter. So let's do that. And then let's play with this roughness again. So there is a sheen on it in real life that's pretty stark, like this one, but maybe make it a little bit more metallic and a little. So that's pretty good. It's shiny, but it's not too shiny. Oh, and before we go too far with all of the materials, I also want to have a normal on this. So if you look at this Bopit closely, it's not a very good picture, but if I had a better picture, you would notice like some scratching on the plastic, some fingerprints. It's a little bit cloudy. So we're gonna see if we can find a normal to use that's gonna make this surface look less perfect and therefore make it seem a little bit more realistic. Sure. So we're gonna make this, gonna do the same thing. They're all gonna be physically based because this is a shiny plastic. So we're gonna make this physically based. Already looks so much better. And we're gonna keep the name the same. Here, my computer fan again. I like to use alpha instead of the default replace, but I don't think it makes a difference in this case. We're going to make it a little darker. And the roughness a little bit softer. So that looks decent. We also haven't played with the directional light yet. So this affects how these types of textures, you see the specular kind of moving on this a bit. I think it looks good kind of on the top, and it won't make a difference if I rotate it. So that looks pretty good, because as I move my face around, you can see the specular kind of moving around. Now that I'm looking at it, the twisted seems a bit too shiny and new, so let's make it little rougher. But that looks pretty good. It looks not realistic yet, I'd say, but it's close. We're gonna add the same normal map. Plastic normal, because I liked how that looked. Can test it. See the ridges on that look pretty good. And I'm gonna make this one alpha as well, even though it doesn't really make a difference. And we have our Bopit. So now let's do the Bopit texture. I want to be able to see this one. Looks like a bit of a, not necessarily a darker purple, and I would say that the body actually has to be a little bit more of a rough specular. That looks pretty good. We got some nice lighting happening. We might need to add another scene light, but I think I like how that looks. Maybe let's add a second directional light. Make it more straight on. A little bit lower so we can differentiate them. And then now when we move it around, there's more sources of light on it. Now that's starting to look a lot better. You can see the plastic and the normal that we just added kind of working with that Bopit. Oh, I think I just messed up this. That looks pretty good. Okay. So now let's do the Bopit button, arguably one of the most important parts of the Bopit. Let's change this to physically based. And alpha. Alright, so that is looking a little light. The material on this button, we're going to cheat. We're going to have two objects with two materials layered together. So we're going to rename this if we can. Oh, awesome, we can. Bopit button shiny. And have it on the shiny button layer. I'm going to charge my computer. Good. Okay. And now, let's see. So the texture is Bopit 10. Let's rename it. We can't rename it yet. Okay, let's go to physically based. And then it jumps down to the bottom. And we're going to call it Bopit shiny. And because we imported this twice, we now have two Bopit textures. They're exactly the same texture, so we don't need those. So let's change this to Bopit text, and let's delete Bopit text 0. There we go. Now, remember how when we made the main Bopit layer metallic, it was looking too much like metal, and this is plastic. So instead, if we make this an add layer, it's only going to add those little speculars, which is exactly what we need. And then we'll make it a little bit less rough. And then we'll add everything we had before. So for this one, maybe we can add the normal texture because we're going to soften it a little bit. And let's add the environment texture. There's a bathroom, which is pretty funny. And I'm thinking that that's looking a lot better. And we can even lighten it a little bit. So now our Bopit button's shiny, just like the original one, but it's still like that dark enough purple that it doesn't look super wild. So the next and last thing we have to do is this little pull tab. It should be exactly the same turquoise color. We're gonna have to kind of match it by eyeball, but honestly, I think it's fine. So that is still gonna be up here because we haven't affected it yet. Scoot over so you can see it. I'm gonna make that physically based. That's pretty good just right out of the box. Metallic. It looks pretty good. It looks pretty good. It's not the right shade though, so let's lighten that a little bit. And that feels a bit too green. That looks not bad to me. And as much as I hate scripting, and I wish I didn't, but I do, I think we're gonna need it to make a counter so that we can count our points and display how many points someone's got as text back onto the screen through the patch editor. So what we're gonna do, let's collapse all of this stuff. Boop, boop. And we're going to add script. And we're gonna call this counter.js. Okay. We're gonna need to bridge the script to the patch editor. So let's do toScript number, and we're gonna call it let's just call it value from patch. Okay, now we're gonna add this to our patch editor. Boop. We want face, and then clean interaction, and we want, what was Bopit? Head nod? Yeah, head patch. So we want head nod as one of them. We want, what was the head state thing called? Head rotation? Yes. Add patch. And then there's left, right, lean, forward, back. So this back works. Okay. So we have head nod, we have back lean state, and then we wanted to do shake, the last one. Head shake. So I think that's working. Let's add this to a counter. Okay, and then maybe add the count here. 1, 2, 2, 3, 4. All right, so that seems to be working. Let's just test it with all of them, shall we? This to a counter, and you'll notice it added a pulse in between because of how this one is set up logically. Can I explain the difference? No, I can't. Back lean, and we'll put that up there. Let's see. 1, 2. All right, that's working. And then we have a head shake. So we have our 3 things here. We have our value. Let's add it to the head nod again because that one was the easiest to do. Make our counter. So we're going to use 2D text object. Oh, and it froze everything in frozen. There we go. And we all know that text is highly illegal in Spark AR. So instead of having this be 2D dynamic text, we're going to take our canvas and we're going to put it in world space. And then we're going to set up the same logic that we did up here, but for the score. So let's do this. Copy all of this stuff. We can change the values in a moment, but instead I'm going to do it for the position. Look at that, magical. And the rotation of the canvas. Now this is good. This is moving with the face. This should get approved per this rule, but we'll see what happens when we submit. Bopit color. And since we don't know what kind of background people are going to be up against, we want to add some sort of contrast. I think the easiest way to do this would be to simply duplicate it and call this one score number back. This will be our backdrop. Let's make this one maybe light yellow, so that contrasts pretty well. A little bit more orange. we'll put it behind here. So everything breaks. There we go. So you see the hierarchy. This renders on the top, this renders behind it, and then we are going to ever so slightly offset it and make it like 62. So you can't really see. There you go. So now you can see like the background of what we have. Maybe let's make it 67. There, I think that's kind of fun. Gives a bit of a flair to our score. We can play with that and how that looks later. I'm going to do my best to walk us through the code portion of this. I am not very good with code, even though it was part of my degree in university, and I got a little help, so I want to thank my boyfriend who I bothered during this section, and Tomas, sorry if I butcher your last name, Pietrovallo, who helped me out, at least with the simple part of this. We're going to see if I can do the complicated part by myself. So what we set up before, we have the value from patch, and you did that as your to script. Really important that you get the capitalizations of this right. I'll probably include this script once it's finished in the description, in a GitHub or something, but I just want to walk us through this because it was a little bit hard for me. So let me cover my face because I'm lagging. So we see how I did this little highlight here, and they're two separate numbers. I found this script, let me find it, actually originally through a tutorial, not this one. So new color, I took this script from here, from his GitHub, and adapted it a little bit just to get the base of this working, so that you take a number from the patch editor, which is our head nod. Didn't work. There we go, which is our head nod, and get that to work in your dynamic text here. So what we have is our scene. We want to set up our scene. We want patches to work. We want diagnostics to work, and I threw in face tracking because I might need that. I'm honestly not sure. And then I named my front purple number score number, and my back number is score number back. So we want to call these both into the scene using a find first, which I think just means that you find the first thing that has this name. So you can use first for both of these, because it's not like find this one first, find this one second. It's finding this name first. So they're both, that works. This was just in diagnostics testing when I wasn't I couldn't get it to work, so ignore that. This is important, so your score number, I don't remember why one is a 0 and one is a 1, but even though these are reflecting the same number, they need to be different arrays, I guess, if that's an array. Honestly, I'm so bad with code. And then you want to get your value from patch, which is this guy from your patch editor. Make sure that your capitalizations are correct or it won't work. And you want to make sure that that value goes into your score number text and stores it in a string using the .toString method. So this is working for now. We'll see if I'm able to make this more complicated, because our goal here, there we go, is to get the value from your head nods, your twists, and your head back. And if you see just now, I did a twist and it recorded as a head nod. So we need to make sure that that doesn't happen too often. What we want to do is figure out a way to signal that you want to either bop it, twist it, or pull it. And to do that, we're going to need the little animations that we worked on earlier. So let's import those and then figure out how we're going to do this along the way. So let's see, 2 of them were an animation and 1 of them will animate within Spark. So let's do the animation within Spark first. That would be the circle. Open. No compression. Let's unfreeze me. There I am. So this is how we're going to get people to know that they need to bop it. I also want to try to add audio, but we'll do that one at a time. So if we go to the Bopit parent, let's add another null object, and we're going to call it signals. And move this into the Bopit parent. It's going to get really choppy while I'm adding these objects. And then we're going to add another null object. And we're going to call it Bopit. Let's just duplicate this one. Twist it. Duplicate. Pull it. Cool. And inside Bopit, we're going to add a plane. We're going to call this circle 1. Okay. And this, we're going to move the container for so we can again work non-destructively. And let's add a material and create a new one. We're going to call it circle signal, just so we know what it does, because circle is a little too general. We're gonna, let's do standard. Circle, okay. And we're gonna do, that is a little bit bright. Let's do associated alpha. Okay. Oops. Okay, and then just registered a nod. So we got that texture. Now what we want is for this to play through like a sequence of animations. So let's duplicate this. I have something in mind, and we'll see it a little bit better once I start to really build this out. I think that should be good. So let's see. Bopit, and we want to make this animation. Let's build this down here for now, and we'll figure out how it's all connected later. We're going to make this a scale animation. We need a transition patch. That's what moves the value. So if we're animating how big something is, we only need it to be a number. That is a lie. We need it to be vector 3, because scale has 3 parts to it. We're going to go from 0 to 1, because this is at 1 right now. And we'll test this with a screen tap until we figure out frozen. There we go. Until we figure out what we want to do. And let's do elastic in and out for now. Okay, tap. So that's kind of fun. I want it to cycle, so I want it to be mirrored. So we need to do this. What we need to do is once the animation is triggered, it'll play for a whole second, and then after that second, you want it to reverse. So add a delay patch. 1 second to reverse. So there, when it plays, and it reverses, and I know I need to bop it. Nice. So let's see if we can figure this out for our other animations. So we're going to close Bopit, and let's do Twist It. So Twist It is actually a 3D object that we exported earlier. We're going to import a new animation sequence, and we're going to choose the texture. This was the twister. 0 to 10. Open. Ah, beautiful pause screen. Look how radiant I look. Alright, while that's loading, we're going to go to the textures. We're going to click no compression and let's refresh me. Come on, computer. You can do it. There we go. It's going to be a little laggy while we're doing the animation sequences. And I know for anyone who's going to come up in the comments and talk about SDF, we can definitely do this with SDF textures, but I don't feel like trying to right now. So let's go to Twist It. I'm going to take our model, put it into completed Twist It, and then Twist It. We're going to move the parent object. We're going to rotate it this way. Make sure that's a flat 90. Let's just make this 0. And we'll make this 0 as well because they're so close. So I think that's about where we want it to be. There we go. Okay, it's very broken. So let's take a look at that. This going. Let's do the same test with the screen tap. So what we're going to need to do is what we did before, but it's a little different because this is an animation sequence that we built outside of Spark. So we're going to do current frame. And we're going to do the same setup here. And then our progress. Transition, there's a new sinusoidal. And we want this to be a number, so it's going from 0 to 11. And tap. So that seems to work. Maybe 1 to 11. No, 0 to 10. That's our issue. There's only 10 frames with 0. There we go. So now we have what tells us to bop it, what tells us to twist it. Our twisted, I think we need to add a little bit of, let's see, maybe an emission would be fun, like a lighter green. Let's see how that looks. Yeah, that's fun. Let's add that same emission to the circle. We'll do the emission and we will add similar green color that I just added. The other one, let's see how it looks. Fun. Okay, I like that. So our bop it one is a little bit more obvious than the twisted and the pull it, but I think that'll be part of the fun of the game. So let's build out this last one here. It's going to be a pull it. And we already know that I have those numbers wrong, so we'll rename them. Lesson learned that the 0 thing doesn't really work in Spark. Now we're going to add a plane because this is not a 3-dimensional object. Plane, we're going to call it pull arrow. Completed. Oops. Okay. And we're going to move the null object for this one. Move it to here. We'll make it smaller if we need to. And let's add a new material. Let's call it arrow. Okay. Pull it arrow. And we're going to add a new texture. Sorry, we're going to add a new animation sequence. We're going to call it pull it. Completed. We're going to spell this even close to right. Every day is a challenge. All right, new image texture. And go to our arrow. Do we have more on this one? No, we don't. Go to 0 to 11. Open. And I'm going to be frozen again. Hello, frozen me. So refresh. Boop, boop, boop. Oh, that arrow's going to be really big. I can see it. There we go. All right, that is large and in charge and very fast. So we're going to need to slow that down. Let's go to pull it. We're going to do 10 frames per second. And we're going to do this. Okay. Now we know we need to rotate this. -90. And that is not what I wanted to type in. Okay. And we're going to make so let's see how that works. 3 triggers. We're also going to probably add audio. But for now, this is what the user will see, and it'll direct them to either bop it, twist it, or pull it. Welcome back to today's episode of Let's Watch My Hair Get Progressively Greasier. If you did make it this far, leave me a comment complimenting my haircut because I did just get it, and we can see who the true tutorial heads are. So now I'm going to move into explaining the logic for what's going on here with our Bopit and the interactions with the 3D model. I apologize that I didn't build this live in the tutorial, but if I did, it would be 9 hours long, so we need to do it retroactively. I also changed a few things. So the nice thing about filter creation is that it's the same as any other creative art form. It's always good to take in feedback, and I did a little touch base with my other housemates and realized that the head motions that I'd chosen originally for Twist It, Bop It, Pull It, whatever, weren't the most intuitive. So I'm going to explain this patch editor logic, but first I just want to show you our new motions. So now we have, I can just do it along with the Bop It. Bop It is still the same. Twist It is now this, and Pull It is this. So it's a little more intuitive. Bop It is in the middle, Twist It is this way, and you're twisting your head, and Pull It is this way. So now let's try to get into this logic a little bit. As you can see, this is functioning, kind of. I'm not very good at it. And when you get something, your eyes turn green. Is it not working? Oh, it's working. I'm just not fast enough. Okay. So what I did was I built out the logic. So before we had 2 separate things. So you watched me build out the animations for each thing. So we had the animation here for Bop It that made the circles come together. We had the animation here for Twist It that made the little twisty thing come up. And we have the animation for the arrow, which is Pull It. And then separately up here, I built out a counter. We also did that earlier, but I switched around the things in the counter. So, you know, it counts how many head nods you do correctly, it counts the left turn state, and it counts the right lean state, right lean, left turn. But they were separate. So you could do all 3 of these and the counter would just count no matter what, and these animations would just run on their own. So the first thing that we have to set up, Bop It gives different commands randomly. I simplified it to just 3. I know the real game had like, you turn it over, you move it, whatever. We're not going to do that. I don't have all day. I do, but we're just going to start out with the 3. So in order to achieve that, there's a patch that's very important to all of us. Where am I hiding it? There it is. Called the random patch. So the random patch is going to give me a random value from 1 to 3. If you put 0, 0 will be one of them. But we just want it to give me 1, 2, or 3. And then another important thing you need is the round button. So the random is returning an integer randomly between 1 and 3, but it could be a decimal. I don't remember if integer means whole number. Correct me if you do know math terms. So this rounds it to a whole number. And another feature of Bopit that we are keeping true to the game is as you progress, it gets faster. So there's some actual math going on here that I'm not going to be able to explain because I got help with it, and I don't really understand how it works too much. But basically what we're doing is we're using an equation that I could probably find and put back in here. If I do, I'll edit it here. I don't remember. But it's something along the lines of the runtime multiplied by a value divided by the runtime plus another value. So basically, we have a loop animation. That loop animation is what was controlling these pulses. So if the loop animation takes 2 seconds, say this duration says 2, then 1 Mississippi, 2 Mississippi sends a pulse to randomize, and then that, based on the number that it picks, sends one of our 3 numbers. So our 3 numbers are connected to the Bopit animation. That's all this is. All the scary lines and things, it's just the animation that makes the Bopit circles. The twist it animation or the pull it. So that's what 1, 2, 3 is. So all we're doing here is affecting how often this is looped and how fast. So as this progresses, the number, I have a clamp here. Right now I have it on 5 because when I'm testing it, I want a long time to be able to do the Bopit interactions, and we'll adjust it as we go along. I got one by accident. But what this is doing is it's clamping the numbers, so it has to stay between my highest integer and 0.3, because at that point it's going to be too fast for anyone to play. And then as the runtime, or how long the effect is opened, progresses, this number gets smaller. So the loop happens faster and faster, which means that it's sending one of these 3 signals faster and faster, making the game harder as we go along. So all of these patches here, there's less complicated ways to do this. This is basically just an algorithm written out in patches that exponentially makes this number smaller between 0.3 and 5. But it starts at 5 for now, 5 seconds. So we'll probably move this to like 2 or 3 seconds once we're ready, because you have to keep in mind that an Instagram story is 15 seconds long. So you're going to have to start out relatively hard, and it's going to have to progress a little bit faster. So we'll change this number as well. But I'll plug that algorithm in there later that we used. Another thing that I'm affecting here is how fast these animations are. So the twist it, when you first start, takes a little longer to twist, and the bop it takes a little longer to bop, because you're just learning and you're just warming up and you want to see which thing you're supposed to do for longer. So that's what this is doing. So I'm clamping it between 0.3 and 1 second for how long the animation is, and then it starts at 1 second, and as the runtime goes, because this is feeding into the runtime, it's all the same thing from the top. As the runtime goes down, your animations are getting faster, so that when they're giving you faster commands, they're also completing faster, so it all works together. So I'm hoping I explained that part relatively well. Now, the hardest part of this logic, and I had to sit down, I had to talk it out with someone to actually make sure I understood how I was doing this. Originally, these 2 parts were independent of each other, right? So we had, let me zoom out, the 3 commands. So we had the thing reading if I was doing this, if I was doing this, and then registering if I did this, if I did this, you know, if I did this. I'm very good at Bopit by now. At the top here, so it's registering if I did those facial interactions, right, or head interactions in this case. And then down here, it was giving me commands, but nothing was validating that I did the command. So what we needed to do logically is, if the twist animation is selected, so that's output 2 in this case, and I twisted my head, so this is an and patch. Once both of those are completed, then I get awarded a point, and I add that to the counter. So the counter is what awards me these points. So if it pulses it once, it increases the count by 1, and then I have these 3 values added together. You can't do an add patch with 3 values, which is the only reason I have 1 hooked up to 2 at the bottom. And that output is our variable from our script that we did earlier, which turns out the script is simple because I did the logic in the patch editor. Could you do this logic in script? Probably. Could I do this logic in script? No. So that's why we're doing it down here. So this is working relatively well. You can see we've had it running for a while, so it's going pretty fast, but not super fast because we're using that like gentle exponent to make things go quicker. But I'm hoping this logic makes sense. All of these switches here, you can't put a pulse directly into these little and signals, so you have to have a switch in between. But the thing that's important here that took a little bit of time for me to figure out is that you need these to reset. So if, let's say, your right lean, like your pull it is activated, the pull it animation, and this is clicked, it's checked, and I lean right, if these both are on a flip, it would flip the first time I lean right, and then it would flip off the second time I lean right. And the same thing would happen each time it tells me to flip, right? So we can't use flip. And if I just have turn on connected to these both, they'll turn on once I do them and once it gets to number 2, but they won't turn off. They'll just stay turned on, so once you do one motion, it's done and you can't get any more points. So the key here, which was a little bit tricky, and it took a lot of me sitting here going like this, is that these pulses need to control when they're turned off. So whether you get the Bopit command, the twist it command, or the pull it command, once those are turned off, this resets. So your head nod turns this switch on, right? But this turn off is connected to the head nod command. So once the head nod command is off, it turns off the whole thing. So the head nod turns the switch on, it waits for the head nod command is already there, and then once those are both off, it clears off. So we can watch this cycle, it's going pretty fast now. But the left twist, and then I do it, and it'll check, but I missed it, right? And then we're back at the left twist. Bop it, and then I do it. Oh, I'm late. Let me restart so we can actually watch this in real time. It's a little bit laggy. So right lean, it's in the right lean state, and I do it. They're both checked, and then it resets. And then it's in the bop it state, I do it, and then once it goes to the next number, it resets. Twist it, I do it, and then when it moves on to the next one, it resets. It'll take a little longer because at the beginning I have the 5-second delay. But when I say move on to the next one, it's when this pulse changes. So this, back to what we were talking about before, coincides with how fast the runtime is changing. So let's make this logic a little more game playable. So 5 seconds as a potential in between is way too long. So let's make it like 3 seconds, and let's make this, that's way fast. Let's test this one more time. Okay. I can't really tell if I'm missing points because it's going really fast now. Okay, so I think this is good because it gets insanely fast relatively quickly, and I think it'll be challenging enough. I did leave a few things left for us to figure out together, I need to animate the buttons. So you've noticed that when I complete something, my eyes turn green, which I think is fun. It's not haptic feedback, but visual feedback that feels haptic because your eyeball's changing. I also want, when you bop it, twist it, pull it, I want this to twist, I want that button to indent, and I want this to pull like a real Bopit. This is sort of distracting. So let's see if we can turn this off just for a minute. Okay. Just a quick pause. It's driving me crazy. So, I am frozen. Cool. Alright, and we also have to add the icons that display before you play to tell you how to do these head motions. You'll see it in the demo video, but I also want people to be able to pick it up if they don't watch the demo video. And then the last thing that we have to do, I think that's it. Add the no instruction icons, that's illegal. Add the intro icons, add the game over logic. So if you miss or if you do the wrong thing, the game over screen comes up, which I'll show you in a minute, and animate the buttons to coincide. So let's animate the buttons first, because I think I get how to do that. So the eye color, right? You notice that my eyes were flashing green when I did something right. These pulses here are the output of the and signal. If you do the right motion and the right motion is what was asked for, then you get a little checkbox from the pulse. So what I have this pulse attached to, a bunch of switches because that's just how it is, and a bunch of ors because I need it to be, you know, this one or this one or this one can trigger the eye to turn green. So these two ors are attached to this one because just like the and patch, you can only have 2 inputs. So this is how you make 3 inputs. And then there's a pulse, because that's just how it is. And then I'm fading in the green. You saw the green fading in. So all this is here is a mix patch. What a mix patch does is it takes one value, whether it's a number, a color, whatever, and it mixes it with a second value. But the great thing about the mix patch, I've had the hiccups for this whole tutorial, is that there's an alpha. So on my eye texture, boop, 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 eyeball map, I have, if you can see here, the texture is the default, the Spark texture thing, you know, this whole chunk. These are called blocks. I don't use them because they scare me and learning new things is hard. But I can affect the emission. So my whole eye emits a green color. The Shiba next door is barking. The whole eye emits a green color when you complete one of the 3 things correctly. That's basically all this is. And then this animation patch here, this pulse turns it on, turns the green on, and then once this is completed, it resets it, which means it reverses it. So that's why the eye flashes green and then it goes back to normal. That's basically what this logic is here. So you attach one animation patch, you attach the pulse to play, reset, and then when this one's finished, animation 1, which is green on, finished, and then animation 2, which is green off, starts and finishes. And those are triggered or pulsed when you do one of the 3 things. So all we have to do, ergo, is when one of the 3 things happens, we have to trigger a 3D object animation. The easiest one, I think, is going to be the twist it. So let's click. That's not it. These are our signals. We don't need that. We want the Bopit. Twist. Awesome. So here, still using a trackpad. Here's our twisty boy. And if I remember correctly, you twisted it forward or backward. Right now the rotation is at 90, 0, and 0. So we're gonna need to set up that same eyeball logic, animation, pulse, because we want it to play one way and then play back. We're gonna just copy that. This is super useful. If I remember correctly, I found this hookup from, let's see, I'm gonna go on my phone during my own tutorial. Eddie, our Lord and Savior Eddie, posted, Eddie Adams, if you don't know him, he makes wonderful tutorials and is a very talented Spark and VFX artist. Posted a comment thread, started a comment thread in the Spark group about people's favorite shortcuts, and I think this animation shortcut came to us courtesy of Luke Hurd, another wonderful shining star. So we're going to use the same logic, and let's make sure it matches up with the right thing. So this is attached to nothing right now. I just copied the patches. You can Command-C, Command-V patches just like anything else. So let's do Bopit first. So if this is true, this will pulse, just like everything else, and it didn't unhook anything. We're okay. Once you get all the little strings in there, you gotta make sure nothing unhooks. It's kind of a pain. And let's move these so they look a little prettier. And now what we're going to do is we are going to add a transition patch. And this is affecting rotation, so we keep it at vector 3 because there's 3 values for rotation, X, Y, and Z. And as we saw here, our final state needs to stay at 90, 0, and 0. And then if you want to see what state you need to change it to, you can just test it here. So we want to change the Z axis. Probably like -90, it looks like. We need to keep it rotated 90 degrees because that's how we affected it initially. Good example of why I shouldn't be rotating the object itself. I should be rotating a null object and have the object correctly oriented already. Totally fine, we all make mistakes. I'm cubing too. So we're going to set up the logic for all 3 of these and then play and just see if it works instead of testing them out individually, because I like to run things fast and wild. Okay, it is really subtle, but the buttons, if you look in the screen here, are working. So when you twist, it twists. When you pull, it pulls it. Come on, you may bop it. See the pull? Twist is hard to see. I'm gonna bop it for a really long time. There we go. When you bop, it bops. So you see the buttons going. It's a little harder because the Bopit is small, but we have that working. So now what we need to figure out is the logic for the game over screen. And let me show you the game over screen. I have it right now hooked up to touch. I think I actually unhooked it. Yeah. A good way to test, I'm not typing, to test things before you actually hook them up is, nope. Is with the screen tap. Screen tap. Nice. And I will demonstrate. Click. Game over. So where we left off, I was working out the logic for what triggers a game over. As you can see, I've decided to change the copy because I think "you got bopped" is a lot funnier than "game over." So the logic here gets a little bit complicated in the patch editor. I want to walk us through it, but I'm not going to spend too much time on it because this is very specific to this game that we're creating. And what I want you really all to get out of this video is the fundamentals of everything we move through and not necessarily the granular on how to make this exact effect. So the important pulses that we have here in our game over logic section, we have the pulses where the Bopit is telling you to do something. So the Bopit pulse, the twist it pulse, and the pull it pulse, these flash when the user gets that command. And then the other important input we're getting is if you completed it. So did you do the Bopit action? Did you do the twisted action? did you do the pull it action. And I quickly want to show you, I decided to change one of our gestures. So before, Bopit was a head nod, but that was actually taking up too much time because you have to nod your head fully forward and backwards to get it to validate. And it was kind of proving to be impossible once it started to go faster. So our new logic is just going to be a head lean back because it's hard for users to do that by accident. And leaning forward is a little bit easier to accidentally trigger. So let me show you. I'm going to restart this. We're going to play a quick game. So you can see the new motion. So now Bopit is a head back, which is a little bit easier for Spark to pick up than a head forward. Oh. So those both came in really quick succession. We can fine tune the mechanics of the loop and how often those commands loop, but now you can see like the basic gameplay that we have going. It's running pretty smoothly. It doesn't work perfectly, but I want this to be more of a use case on how you can build an effect like this and not necessarily a means to an end to creating a perfectly functioning effect for like a corporate account. So back to this logic here. Basically what I set up is we are validating within a certain amount of time if you do the Bopit action. So if you get that Bopit pulse, it's going to turn on this top switch. So the and at the top will be checked. And then you have however many seconds. So this delay is being fed by another number. That other number is somewhere else in the patch editor, and it's how fast the commands are going. The delays also have to get quicker. So this delay tells you how many seconds you have. So right now, like 5.5 seconds. I made the Bopit one a little bit longer because it takes longer to do this action. I could probably make it a little shorter, honestly. Let's move it back to 0.4. So this is an ad patch, 1.4 seconds. If you don't do the Bopit lean, this second box will check. And then when both are checked, it will trigger this pulse. And this pulse is what triggers our game over screen. So it builds in the value of the game over. So it goes from clear text, the you got bopped is clear. It turns into white, and the red overlay screen gets put on the screen that we built earlier. Another important thing that's happening that I'll move us through is that the score stops counting. So I'll show you how I did that because that was a little bit confusing. But the important thing here with this logic, let me make myself a little bit smaller so we can look at it better, is that if you see this checkbox here, the correct motion, this triggers the top switch to turn off. So the Bopit pulse that tells you to bop it turns this switch on. And if in 1.5 seconds you turn the top switch off, you won't get bopped. Which, I just love that phrase. So hopefully that makes sense to you all, but that's the basic logic. There are millions of ways to do this. I wanted to use a delay patch instead of an animation patch because it makes more sense to me logically. You know, if you don't do this in however many seconds, delay 1.5 seconds to turn on this switch, but you can't change this. There's no value input for the delay patch here for the duration of it. So we're using an animation patch instead and making sure that you reset it each time so that it can run each time. Boop, 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 boop. So what did I just tell us? Okay, so now the logic to stop the points from getting counted, because an issue I was running into is that once the game over screen comes on, if you happen to guess, I was hiding the signals that were telling you to bop it, twist it, pull it. When you lost the signals, I turned invisible, but they were still running in the background. So if you moved your head around after you lost, you could still accidentally get points after the game is over, and we don't want that. So in order to stop that, I'm taking the pulses here, right? If any of these are activated, then you lose because you didn't fulfill what's needed in the amount of time. So that distills down to this output, basically. So I took that output, zoom in, I named it a stop the count pulse. So if that gets triggered, you've lost. Added it to a switch because once the game is over, it just needs to turn on once. You can't reset the game without resetting the lens. I could make that happen. I think it would be too complicated. So this switch turns it on, and then what I have is I have it added to a not signal. So this here is the logic that we set up for how you get points. if you bop it, if you pull it, if you twist it, if you do these actions, you will get a point. And it's validating those switches. If you do the action at the same time that that action is called for, that's what these ands are, then you get a point. But if the game over pulse is activated, it'll turn on this second checkbox here, and this will stop it from adding points. So usually if we were playing, and I can restart it so you can see this second box would be checked because our game over pulse wouldn't have checked this box yet. And then when you get a point, both boxes are checked and it'll award you a point. But when this not signal is on and the game is over, it's impossible for this and to be totally filled because this second box won't be checked off your ability to gain points. So the counter will stop counting. There are definitely other ways to do this. This is the way that I figured out works relatively well. The finishing touches that I wanted to add to this is the intro screen. So none of this is going to play right now. It plays automatically. I don't want any of this to play until the user starts recording so that you know that you've completed what was asked. Oh, sometimes the animations get a little stuck. We can work on that. It's not easy, but once you've practiced for as long as I have, it's not too hard. As you can also tell, while the gameplay moves forward, things get faster. So if I had gotten that signal earlier and done it in that same amount of time, I would have been fine. But because we're further along in the game, I lost. And because we have to think about the end goal for this is going to be on a story, it has to get really hard really fast because people are only going to film for 15 seconds. You could film multiple stories, but I don't think anyone's going to do that. So we have to work within that parameter. So what I want to do now is change this because this is accompanying for the lag of refreshing in Spark. But I think when people are using it, maybe we'll give them like 1 second or 1.5 seconds before they start. If the camera is recording, then you can add the runtime and it'll also reset on record. So it'll go back to 0. Otherwise, add nothing. So this is kind of what spurs the entire thing, and it spurs all the animations looping, and those control if your registered head movements get counted and things like that. So what we've set up is that when I open it on my phone, this will be hard to show you. Tiny bop it, you can see it. So if I send this to my phone, you see the little bop it there. Before I start recording, there's no signals, the game hasn't started yet. And then when I start recording, I don't know if you can see it, there we go. You see the signals and the game playing. So this gives users a second to orient themselves and figure out what's happening, and they see the bop in front of them. They're gonna see the icons to show them what head movements to do. We're about to add them in right now. We're going to add those icons in right now. We made them earlier, so I'm going to pull them up and import them. But first, let's make a place for them. So I'm thinking that they should sit right above the Bopit in the areas that they're going to pertain to. So just like how we made a signals null, I think that we should do the same with the icons. It also needs to be inside the Bopit parent because this placement, we want it to move with the Bopit. So again, we're working non-destructively. It's so easy for me to add things in because we have this invisible bubble that we can add stuff into. So we need 3 materials for those. So let's create a new material. We're going to call this the full icon. Was a right lean. Oh, looks good. Bop was the head back. Nice. Twist was the left twist. Nice. So these are our icons that kind of show users what motions to do. I think that they're relatively clear. And to draw some attention to them, so we're going to add a little detail here. Let's move to an empty part of the patch editor. I think I want them to float a little bit. So we're going to take our start icons. We're going to take that parent instead of doing each one. I'm going to use a default action from Spark, but we will adjust it. And I want it to animate and I want it to float. Face. I think it's relatively important if face gestures are part of your effect to keep your face kind of visible so people don't feel detached. So this looks pretty good. See this enable for? Just check it off for capture. And that made this mad for some reason. Wow, look at all the capabilities we're using. So many. Not sure what capability is not being used. So I'm going to test this on my phone. I want to see if the experience kind of works with the icons moving away when I start to record. But I think that this is relatively clear. And also, we're going to have a demo video, and it's going to be demonstrating each one of these motions so people won't be super lost if they find the effect on my profile. The icons go away on capture, so you can still see them when you're recording, but you can't see them when you're ready to share the effect, which I think is a good thing. We might change this. So the last thing that we have left to do, which I think is one of the more important things, is I want this to work like a Bopit. I want it to say bop it, twist it, pull it when it gives those visual cues. So if you happen to have your sound on, you can also hear the cues. So we're going to set that up right now. We need to figure out where to attach these sounds. So here is one place. When you get the trigger visually, we want the trigger, pull it, twist it, bop it. When you actually do it, so when you bop it, pull it, twist it, whatever, we want that as well. So I need to find where we did this. Also, fun tip, if you don't know this necessarily, if you've lost something in your convoluted patch editor, but you know it's bridged to the patch editor, you can just click on this and it takes you to it. So this is happening here. And okay, yeah, so we can work with this. This bottom one is the twist it switch. Make sure to label your patches. I'm so bad about it. Twist it, done, we'll call it. Right lean, pull it is the second one. Yeah. Pull it, done. And this one's bop it, done. So this is the other place that we're going to trigger our noises. Let me delete this extra patch. Move these guys out a little bit. And I'll make a comment box so I can find this. We're going to call it action completed. And anything that's audio related, I'm going to make it green, because I don't think I've done green yet. So we're going to need this. When the action is completed, there will be a sound effect. We're going to need, oh, I did make something green, that's okay. This, when the action is requested, there's a sound effect and background noise, which we'll do separately. But for now, let's find some noises. So I think I'm going to make some, which might be embarrassing, but it's happening. And then I'm going to find some royalty-free open source sounds. So my favorite place to do that is resound.org. Audio. I use Audition for audio editing, but there are definitely other tools you can do this with. Spark requires you to export mono M4A files. They need to be 44.1, I think this is kilohertz, not sure, and 16-bit depth resolution. So we're going to be able to do that here. First, I want to shorten my clip, bop it, because there's a lot of noise. So I can just select this, delete it, bop it, bop it, bop it. So that's pretty good, I'd say. And now we need to convert this to mono. I believe I have that in my favorites.
Bopit.
And then we export. So we're going to export the file. I already have M4A, but so you know the format, it's Apple Audio Toolbox with all of these things listed, and you can type in M4A, and then I'm going to put this in our audio folder. Bopit instruction 01 M4A. Okay. Let's check and see if that works in Spark before we do all the other ones. So I'm going to go to add my asset, audio, and it looks like it's working. So I'm going to go ahead and do the rest of the clips that same way, and then when we come back, I will show you how to get them to play and hook them all up correctly. So now we're going to add the audio. I don't work with audio too often in Spark, so I'm a little bit rusty, but we're going to do it together. So I have all of our sounds in here. We're going to do the background noise first because that one's just going to be playing by itself and it'll be a little bit easier for us to do. So after you've imported the sound, you need to make something called an audio playback controller. Boop. We're going to call this one BG for background music. You pick which audio you want. So we want the background music 01. I am frozen. That's fun. There, I'm unfrozen. We're gonna hit play and loop. We're gonna add a speaker to our scene so that we can hear the audio. We're gonna call this one background music. And we're going to hook up our background music to it. So now we hear our music. We want the background audio to play when the user starts recording. So what we're going to do is we're going to take this background music, we're going to take the play tab, boop, and we're going to hook it up to video recording. So when we record, this should play. Let's test it on our device. And keep in mind, if we are keeping the microphone input as well, in Instagram, users can't hear your background music when you're recording. But if you disable the microphone, so if you go into it and you disable, then people will be able to hear the noise. But I don't want to get rid of people's reaction noises, so we're going to keep the microphone enabled. So here's my effect. I'm going to turn my sound up. Let me record for a few seconds, play the game, and then let's listen back. So the sound is playing. To add the Bopit instruction M4A. Not sure why this freezes the program every time, but it does, and we'll just have to deal with it. And we're going to play with the play properties and the reset properties. So every time this is triggered, it should play it as well as reset it. I'm going to do that with my other three. The last thing you have to remember to do is add speakers for all of these, which I forget all the time because your sound is an object in the scene, and if you don't put it in the scene, you won't be able to hear it.
Twist.
So the sound is working.
Twist it. Bop it.
Which is great.
Pull it. Twist it. Pull it.
Unfortunately, if we don't disable the microphone, people won't be able to hear it while they're recording, and I do think it would be good to have, but we're going to leave that for now. So So now that we know that this works, we're going to do the same exact thing, but we're going to do it with the noises it makes once you complete a motion. And we're going to add a game over noise. So I'm going to add all of those and then come back and we'll test it together, and I'll show you how it works on my phone screen. And then I think we'll be pretty much done with this effect, which is really exciting.
Pull it. Bop it. Pull it. Bop it. Twist it. Bop it. No!
All right, now for our final step in terms of the effect, we have to export it. So I'm curious to see what our file size looks like, because I think we did pretty well compressing everything as we were. Nice. All right. And you can see here, this is way bigger than a phone screen is going to be. It's hard to tell on your laptop, but on my laptop. And the quality looks the same. So we compressed one of our textures and it made such a difference. So now we're under a megabyte, which is great. And I'm going to export this file. You can upload directly to the Spark Hub from here. I don't like doing that. I don't know why, but I'm going to export this file. And next we're going to show you the upload process. Quickly recap. If any of you actually watched this entire tutorial, we used so many programs to create this final effect. We made so many materials, so many sound clips, textures, animation sequences, audio, 3D models, UV unwrapping. We did all of that stuff. We used Photoshop, we used Illustrator, we used Maya, we used Audition, we used Spark AR, we used Sublime Text, maybe a few other programs I'm forgetting. It takes a lot to create an interactive augmented reality effect. Not just game effects, every effect takes a certain level of effort. So I hope that this tutorial illustrates kind of why sometimes commercially these are priced a little bit more on the high end, because so many different types of skills and knowledge of programs go into making these effects. So now, for the very last part of this video, our beautiful New York City ambiance of a siren, I apologize. I'm going to go through creating an icon, making a demo video, and publishing the effect. So first, we're going to do icon creation. Quickly pull up the guidelines. Your icon has to be a PNG or a JPEG. It has to be square. It has to be in the RGB at least 200 by 200. Can't be transparent in any way, and doesn't use Instagram's color gradients. So that's pretty straightforward. I'm going to pull up the template that Instagram gives us for an icon and talk about how it's a little bit outdated. So here is the Instagram Photoshop template. I'll still have me in the corner, even though I'm a bit laggy. So this template is a bit out of date. It says that face effects have to use the supplied face shape, but I've come to see that that's not necessarily true. So icons, as long as they don't have too much text and they represent your effect, they seem to be fine with not having this face icon. And I honestly don't love how it looks. And we're going to go through and we're going to make an icon that makes this effect look interesting and make people want to test it out. So let's delete those guidelines. We can delete the hard examples. I'm going to turn off this face layer because I don't think we need it. And I'm going to import some fun textures. But first, most importantly, we need this Bopit. Now, I didn't build out all of these materials in high fidelity outside of this software. I built the materials in Spark. So this is a little bit this isn't the cleanest way to do this, but usually when you're delivering effects for a client, the icon is kind of an afterthought, and typically the client doesn't care that much about it either. So spend as much time as you can to make it polished, but don't go crazy. So what I'm going to do is I'm going to screenshot the Bopit. I'm going to move my face. Boop. Maybe tilt, put it on a tilt. I'm going to screenshot it. And then we're going to clean this up in Photoshop. Put it into Photoshop. There's a little bit of aliasing happening here because we're zooming in. Don't worry about that. I'm going to cut this Bopit out from the background so you can't see what I did, but I just chose this tool, but I did it on my touchpad. So I'm just going to highlight the Bopit because I want to cut it out from its background. Make sure you get the blue and this black down here. It's hard because it's up against my gray background. Make sure you get here, my gray little sweater. So I think this is all highlighted. You can use this tool here. This is a feather tool, and just get really in with that mask. So I see that I got a little bit of my sweatshirt here, so I don't want that. I got a little bit of junk here, little bit of junk here. Otherwise, I think this is relatively clean. Maybe a tiny bit here. So I'm gonna click OK. And with this black background, we can't really see the black Bopit very well, so I'm gonna turn it to like a chroma key green. So that's a pretty decent cutout. This Bopit doesn't look too bad. There's a little bit of artifacts happening there. We're going to just take our eraser tool, make it super small. Shortcut on the keyboard is the square left parenthesis for making something smaller. Make sure we're doing the right layer. I'm going to erase the mask that was created because we just don't want that part being masked out. And I said that looks pretty good. The bottom of this got a little cut off, so we're just gonna make this a smoother edge. And again, you can totally make high fidelity 3D models and get a better rendering for your icon, but the icon is gonna be this small and it's gonna be on a cell phone. So you really gotta keep that in mind. Now, typically icons shouldn't have text in them, but this is gonna be small enough that I think it's okay if it has text. The Bopit is so small, I really don't think it matters. So I'm gonna center this. I'm gonna add like kind of a fun background. And then I think that's all we need. We don't necessarily need the face. I don't want the icons. I don't want the score necessarily. I just want to keep this simple. So now we're ready to publish our effect. We have an exported effect file, we have an icon that we made, and we have a demo video, which I just shot. So to upload your effect to Instagram or to Facebook, you need to go through the Spark AR Hub, which is a web app. So all you have to do is open any browser, type in facebook.com/sparkarhub, and if you're not logged in, you just need to log into your Facebook, and that needs to be connected to your Instagram. In terms of naming, you can kind of game the system and use keywords in your name that you think people would type in, like beauty or cute or things like that. But I like to name my effects pretty literally so that if someone is looking for something similar, they can find it. I'm going to add the word game. So if people are searching for games, this might come up. And then we're going to upload our effect file. Notice that it says that it's a maximum of 40 megabytes, but that doesn't count how big your effect file has to be when you export it. So Spark checks to make sure that on phones, it's under 4 megabytes. Here's our export, Bopit 1. I'm gonna upload that. I wanna publish just to Instagram, mostly because I honestly don't know how to access Facebook effects. So we're gonna turn Facebook off. I think I'm gonna publish this to my personal Instagram, not to my studio Instagram, but maybe we'll do both. And for categories, it's definitely a game. I guess we could say that it's funny. That's kind of it. I mean, I like to add more. They can take these off if they're not appropriate, but usually since you can add 4, I think that you should add up to 4. So we'll just pick a couple random ones. And then I'm not sure if these keywords actually work, but we're gonna try it anyways. Games, fun, Kira, sparkles. I don't think the keyword searches actually work yet, so it doesn't really matter what I put here. Interactive, LUT, beauty. Just some troll words, really. Skin smoothing. Actually does have that. And now we already have our video file, so I'm going to choose the video that I sent to myself. And then once that's uploaded, you'll be able to pick a thumbnail, and the thumbnail is what people see before they click the video on your profile. This is taking a little longer. There we go. .jpg. And then in the notes for the reviewer down here, I think that most of these effects are reviewed by bots, so it doesn't really matter. So I'm going to put fun game. You should try it. Smiley face, because no one's really going to read this. And then I think that's it. So we have this, we have the audio. I think we're ready to submit. Final step, we submit the effect. And there it is. Now all we have left to do is be patient.